Physics Bites.
Physics Bites,
A science podcast in English by the students of Notre Dame d'Aviation.
Hello and welcome to Physics Bites, the English language physics podcast of the students of Notre Dame d'Aviation here in Paris. A new episode again this week. This time we're talking about aviation. We have two new experts who are in my class since grade 10. They both actually did their certification, the first step of their certification to become pilots. And so it's a subject that is close and dear to their hearts. And they're going to share some of that expertise with us with a bit of a physics flavor to it. So I'll let them introduce themselves. Go ahead.
My name is Maelys.
So we have Maelys and
Myriam, hi.
And Myriam. You guys were also working together last year in our carbon emissions project, if I'm not mistaken, in the same group, right?
Yes.
You guys were on the textile group, I think.
Yeah.
Yeah? You're not, you don't remember. Such a long time ago. Okay. So with you guys, we had a bit of a time deciding on what topic you're going to talk about, and then at the last minute, you decided to go into something which was close and dear to yourselves, which is aviation, which was new to at least me and many of the other classmates of yours. So I'll let you guys get right into it. Whoever wants to start.
I count with a reason of our presentation. Okay,
go ahead, Maelys.
Okay, so in our presentation, Myriam and I took you through an interactive escape game named Weatherwise. There we, our teacher, our classmates, and ourselves assumed the role of elite pilots tasked with delivering a top secret package. And we choose this format to make the presentation more engaging and to keep the audience actively involved.
Yeah, and it worked quite well, even though we ended up not having enough time to get to all the questions, but it was one of the more original presentations.
Yeah, thank you. And
go ahead.
During this session, we guided you through 3 key sections to ultimately learn how to fly.
Right.
And firstly, I don't know if you remember, but we explored atmospheric physics, covering the composition of the atmosphere, key parameters, so temperature and
pressure and so forth. Yeah.
And the principle of convection. And next, we analyzed more precisely the altimeter and aviation standards. And finally, we studied dangerous meteorological phenomena such as cumulonimbus clouds.
Exactly. So why don't we go through those 3 major axes of what you guys talked about? Why don't we start with atmospheric physics, Maelys?
Atmospheric physics.
Right. So maybe give us the main axes of what we need to think about when it comes to the atmosphere and the physics of it, how it can affect aviation and flight, and then we'll move on from there.
Okay. So the atmospheric physics is basically the physics in the atmosphere, and the atmosphere is a layer of gases that surround the Earth, and is composed of 78% of nitrogen and 21% of oxygen. And there are several distinct layers in the atmosphere, and we fly in the troposphere, yes.
Right. So can you just give us maybe starting from sea level, going up, what the names of the different layers of the atmosphere are, and maybe 1 or 2 characteristics of each layer?
Yes.
Okay, let's do that.
The first one is the troposphere, which extends from the Earth's surface to about 11 kilometers in altitude, and is the densest layer where all weather phenomena occur and where we fly. And above it, there is the troposphere, which stretches from 11 to 50 kilometers in altitude, and it's more stable, so turbulence is non-existent, but we don't fly here. And finally, beyond the stratosphere, there are the mesosphere, thermosphere, and exosphere, where the air becomes extremely sparse.
Right, and that's above normal cruising flying altitude. Which layer are we mostly doing our commercial flights in? So commercial flights are usually in which layer of the atmosphere? The troposphere.
Yeah.
Okay. Maybe you can tell us what is the specificity of each of these layers when it comes to maybe temperature, pressure, I don't know, maybe the composition changes, just so we have an idea of why we are dividing the atmosphere into these layers. Either of you guys?
It's because
So,
in
Myriam?
the troposphere, the temperature goes downward until 56.5 degrees Celsius, and then it starts to hit, and so that's...
So if I understand correctly, what you're saying is that as we go higher, the temperature goes down. Is it like a linear sort of a...
Yeah,
okay.
exactly. And so we divided the layers by how the temperatures behaves according to the altitude.
Okay. Is there a reason why we do most of our flying in the troposphere? Is there a reason we cannot fly in the higher levels?
I think it's because in the troposphere there are four main forces that influence the fly.
Okay.
Firstly, there is a lift, so created by the wings. It balances the weight and it allows to fly.
So lift is basically the reason humans were able to finally fly, right?
Yes.
Okay. Do you want to maybe either of you guys give us a one-sentence explanation of how wings allow an airplane to fly?
Yeah, because I think the wings are shaped to create a lower pressure on top and higher pressure underneath, and which generates lift, finally.
Right, and this difference in pressure is a result of what exactly? Which characteristic of how a plane moves? Either Maelys or Myriam.
Yeah.
So the idea is the speed of the air that's going over the wings, because of this lack of symmetry between the bottom and the top side of the wing, creates a difference in pressure. And the faster we go, the bigger that difference in pressure. Which means that if we go past a certain speed, the pressure difference between the two, which you call the lift, is greater than the weight of the airplane. And that's what helps the airplane get off the ground.
Okay.
Go on. So you were talking about some of the key parameters when it comes to atmospheric physics of flight.
So there are four main forces: lift, weight, thrust, and drag. And lift must stay greater than weight to stay in the air. And a plane must be very, very light to take off and fly. And after that, when fly, the temperature, pressure, density, and weight are key factors affecting flight conditions.
Right. So, for example, how does pressure, air pressure, or atmospheric pressure change the requirements for flying?
It's because pressures varies with altitude, and so when you encounter a high pressure system, the air is forced downward from higher altitudes, and so the air spreads outwards, turning clockwise, and it affects the plane behavior. And so it's really important to know if you are in a low pressure system, in high pressure system, because usually you're not in the standard pressure system. And so that's why it's important to
Okay, so
study.
if you're, for example, a pilot and you're about to take off and you learn that we're in a low pressure atmospheric system, what has to be adjusted? Do you know?
Yeah, it's just we'll see that later. But the altimeter, which take the static pressure, will overestimate the altitude or underestimate the altitude. If the air is cooler, so denser, the isobars, which are the pressure lines that you can find on a lot of graphs, they will go close. They will get close to each other, and so the altimeter will overestimate, and so you'll have to keep in mind that you can't rely 100% on this instruments.
Okay, so I guess we'll come back to that, as you said, when you tell us how altimeters work, which was one of the more interesting parts of your presentation. Okay, so another key parameter that you guys mentioned was the idea of convection. Do you want to maybe go into some detail about that?
Yeah, so convection is the primary method of thermal exchange in the lower layers of the atmosphere. So the basic principle is that the air in contact with the Earth's surface is heated, and so the heated air expands and its density decreases, causing the warm air to rise, which is replaced by the cooler air from the upper atmospheric layers. And so it's a vertical movement, and which is the manifestation of convection. And so the more intense the sunlight, the more active the convection process will be. And so it's important because it causes turbulences in the troposphere as warm and cold fronts.
Right, because convection is the idea of fluids that move from one place to another. There are different factors that influence that, and one of the main parameters that influence that is the differences in temperature, because warmer airs tend to be less dense, colder air more dense, so that creates a lot of gradients and movement. Okay.
Yeah.
You mentioned, for example, solar activity could be linked to variations in the convection of air that has to be taken into account.
Yeah, so basically at 2 p.m. the convection process is the highest because the air has had the time to be heated by the sun. So it's 2 hours the apex of the sun.
Mm-hmm. And so it means that, for example, if you're a pilot and you're flying out from, for example, Paris to go somewhere, the time of the day that you are doing your flight has to be taken into account if you want to fly correctly and avoid dangers. Is that it?
Yeah, absolutely, especially in summer.
Right, because there's even that much more intense heat.
Yeah.
Okay. Well, let's move on to the second thing that you guys talked about, which was the idea of altimetry, and you described the functioning of an altimeter using static pressure and all these. And do you want to give us a definition of what we mean by altimetry, and then tell us why it's important, and then go into some of the stuff that you mentioned?
Yeah, okay. So the altimeter is a key instrument in the aircraft, and so basically we use a high vacuum in a capsule, which is called an aneroid capsule, which was created after French physicists in 1844. And so a spring is placed inside to prevent it from collapsing. And so around the capsule, you have a tube which collects the static pressure around the plane. So
what is static pressure exactly? Why do we need to add that adjective in front, static, as opposed to just pressure?
Static pressure, it's the pressure without like the speed, the movement of the wind, and so the static pressure will deform the capsule, and so this deformation is transmitted to the needle on the graduated dial, and so the altitude, an altitude is assigned to a pressure, and it's based on the standard pressure table.
Right. So the idea, if I understand correctly, is that we don't actually measure the altitude we're at, we measure the pressure, and we know that there is a relationship between pressure and altitude, so that if we're at such a pressure, it means that we're at this altitude.
Yeah, exactly.
Okay. How accurate is this?
It's accurate in standard atmosphere, but it's...
Go ahead,
on,
Myriam, and
Maelys.
then we'll have Maelys come in afterwards, yeah.
Okay, perfect.
Yeah. Sorry.
It's never 100% accurate. So that's why you have to listen to the ATC to know the difference that you have to take in account. So usually they are going to tell you, for example, 1030. And so on your altimeter, you'll have 29, for example.
Okay.
And so you'll have that you have a 1 hectopascal difference. And so you have to always keep that in mind. So when you fly, you add or you subtract an hectopascal.
So when you say you have to do it, do we do it ourselves, or is this sort of taken into account by whatever?
No, you have to do it yourself. You have to memorize it.
Okay, so it's possible that a pilot might forget that?
Not really, because they have paper to note that. So you look at.
Interesting that we haven't fully automatized everything, which is kind of nice. And at the same time, now that I know that, it's kind of scary. Okay, so Maelys, I think you wanted to add something, maybe?
Yeah, maybe it's important to precise that the standard atmosphere is at 1,003.55 hectopascal. And that the altimeter compares the most pressure with the standard pressure to determine the altitude, when Myriam said.
Okay. And I guess the question of knowing what altitude we're at is absolutely essential, because if we think we're higher than we are, then maybe when we're trying to land, we might crash right into the ground, and it could be bad news all around for everybody.
Yeah, and Myriam... Myriam knows that well, because she fly and use this altimeter every Sunday. So. Okay,
and she's still around with us. So thank you for the proper functioning of altimeters. I thank you, atmospheric physics, right?
Don't say that.
All right. What about temperature? Can we just maybe do a little side step and talk about the role of temperature when it comes to flying, and how it has to be taken into account by a pilot?
With the altimeter, or
in general, you can talk about it with the altimeter, but also with other aspects of navigation and aviation.
Do you want to go to start, or?
But how about you start, Myriam, if you have something, and then we'll come back to Maelys.
So with the altimeter, because it's what we talked about earlier, so I said that when the air is colder than standard, the pressure levels isobars move closer to each other, and so the altimeter, like in reality, the aircraft is lower than the altimeter shows. And on the other hand, when the air is warmer than standard, it becomes less dense, and the pressure levels spread further apart. So the altimeter will underestimate the true altitude. And so in general, temperature is really important, because it causes a lot of turbulences. For example, the cold and warm front, which are related to convection.
Right, and I think for you who are majoring in physics this year, it's not too surprising to see the link between temperature and pressure through the ideal gas law that we've studied and worked with. So I guess when we say pressure or temperature, they're so linked together that you can never just consider one or the other in complete isolation.
Yeah, absolutely.
Okay. Maelys, did you want to add anything to that, or?
Yeah, maybe that warmer air is less dense, and which can reduce the lift generated by the wings and make it take off and landing more challenging when there are warmer air.
Okay.
And yeah.
Okay. So maybe we can move on to one of the more interesting parts also that of your presentation, which was all the various meteorological phenomena that have to be taken into account by a pilot or any sort of aviation. Myriam, did you want to maybe get us started on that?
Yeah, we can start with warm and cold fronts.
Okay.
So these forms when air masses of different temperatures meet. And so you have to know first that temperature is relative to one another, especially for air masses. So an air mass is considered warm or cold if its temperature is relatively higher or lower than the air mass it can encounters. And so the second thing you have to know is that two air masses don't mix, but instead they slide against another. It's because they don't have the same pressure, etc., so they can't really mix. And so you'll have two sort of fronts. You'll have the cold and warm front. Cold front forms when a cold, dense air mass encounters a warm, less dense air mass. And so the heavier cold air sinks beneath the warm air, forcing it upward and creating a pronounced vertical movement. On the other hand, warm fronts forms when warm air gradually overtakes a cold air mass, and by being lighter, the warm air slides gently under the cold air, resulting in more moderate upward motion. And so in a cold front, you'll have a severe turbulence because it will cause cumulonimbus, thunderstorms, etc.
Right.
Whereas in warm fronts, it's just the sun.
In general, when it comes to atmospheric physics and climate physics, I suppose, most interesting stuff happens when you have these regions of high and low pressure or high and low temperature that come into contact, and that's where you have a lot of energy being transferred, and energy being transferred is usually at the origin of most weather phenomena, if I'm not mistaken, right?
Yeah, absolutely. But a pilot in light aviation can't navigate through cold or warm fronts. It's too dangerous, so you just have to get really far from those if you encounter.
And how do you get far from it? Is it like a question of flying above it higher, or is it more just like not flying more around it, or just avoiding it in general?
Avoiding it, and you really have to do your pre-flight check really accurately, because you can't put yourself in danger and also others. So generally you'll study the
weather forecast.
Yeah, exactly.
In English, yeah.
beforehand, so you won't be in those dangerous situations, because it's really complicated to
now, is this true of all flight, or are you saying this is more the case for like a smaller aircrafts with like a 1 or 2 person, as opposed to like the commercial aircrafts? Okay.
Yeah, in the commercial with the airliners, they are really heavy, so it doesn't bother them. Even the cumulonimbus, they can pass through them.
Right. I guess this is a question of like, if you want to make an analogy, it's a question of like, if you're going through on a boat through like turbulent seas. If you're on a big cruiser, it's much less of a problem than if you're on like a tiny 1-person boat, which would completely be tossed aside, right?
Yeah, absolutely. And so the wave on the sea that heavier boats create can be you can do an analogy with the wind that heavy aircrafts create also, and that's why you have 2 minutes between each takeoff, because it creates really strong turbulences.
Right, you're talking in the wake of an airplane when it's taking off. It will behind it leave enough of a turbulent air that you can't just go into it because it's too problematic.
Yeah, absolutely.
Okay, that's interesting. It makes sense, but I guess it's not the sort of thing we think about when you're not if you haven't flown already in the past, right? Okay. So you talked about various types of turbulences we can have, which are caused by meteorological phenomena. You talked about mountain wave turbulence, and when you have moisture in the air as opposed to when you don't have moisture in the air. Different types of clouds. Do you want to maybe give us a rundown of that, just very quickly?
Yeah, I'm sure Maelys can talk
or Maelys,
about
either of you guys, yeah.
thunderstorms, because
So we are several types of clouds. The most dangerous is cumulonimbus. So,
right.
Yeah, and these cold fronts which we can predict can create these clouds, because when a cold front moves in, pushing warm most air up and creating perfect condition for storms and for the creating of cumulonimbus. But we have thunderstorm also with when the sun hits the ground and the warm air rises, and that provoke a cumulonimbus too.
Mm-hmm.
This phenomena is called convective lifts, and we have also orographic lifts. When moist air is forced up over hills or mountains, it cools and forms clouds, and after it can create also
a lot of turbulences. Yeah.
Okay. Just so we're clear, when we talk about cumulonimbus clouds, what is the specificity of these clouds?
Cumulonimbus.
If I look in the sky, would I be able to recognize a cumulonimbus?
Yeah, absolutely. They're huge, and that they can
change direction in just.
Are they the big puffy clouds?
Puffy, more like frightening clouds type of clouds.
So the puffy, but kind of like gray, dark clouds where you know that like a big storm is coming?
Yeah.
The end of the world?
Yeah.
Okay. So the danger with cumulonimbus clouds in particular is that they have a lot of, I guess, convection in there. They have a lot of, I guess, changing of temperature and pressure. Is that it?
Yeah, and then they can move at speeds of 30 to 50 knots, and they can change direction. There are every dangerous phenomena.
Okay. So the problem would be that for a light plane, it would be very difficult to, first of all, predict how the pressures, change in pressure would be, and so the plane would actually like sort of get tossed around while it's flying in there.
If you have a cumulonimbus, you usually can't fly, because it's usually followed by a lot of cumulus or middle type of clouds, and so it's impossible to fly when you see one.
Yeah, and as a general rule, it is provided for, and it is then forbidden to take off, isn't it?
But what happens if you actually do end up in something like this? You're in your little single-person airplane, and what happens if you find yourself in one of these clouds? What is the experience like?
Like in light aviation, you can't really fly without if you don't have like a clear view, and so if you go through a cloud, which can be a stratus or cumulonimbus or every type of cloud, you have approximately 3 minutes to live as a statistics, because you are not trained to fly, because like the instruments are not working well.
Okay.
And so it's really not a future situation, as my teacher always said. If you do that, basically.
And you have to avoid a stall. So a stall, called in French un décrochage.
Right. When an airplane stalls is when it actually, if I'm not mistaken, you suddenly lose a lot of lift. Is that it?
Exactly.
Okay.
Yeah.
Which is the most dangerous thing that can happen to a flight during a flight.
Yeah, but I think it will be caused by the ice that the clouds have in there, and so it will go it will go in every holes, which can take the static pressures, etc. And so the weight of the plane will not be really balanced, and so it will create a stall and you'll die. So.
Okay, sounds quite apocalyptic. So I guess what you're trying to tell me is that flying is dangerous. Is that it? If I make a summary.
But exciting also.
Okay. But I guess what is dangerous is often exciting, right? Because you can't necessarily predict how things will go. All right. Out of curiosity, which one of you guys has actually done flying, not solo, I guess, but at least with one other person in a light aircraft already?
So like she said earlier, I'm currently doing my private pilot license. So I'm in few lessons, I will be solo in an airplane.
Are you looking forward to that?
Yeah. I'm
not
really
scary
excited.
at all?
Yeah, this.
Slightly. All right. I could imagine. I suppose just as a curiosity, when we are in like a big, giant commercial flight, when we do have those moments of turbulence, is that for the same reasons? Is that when we're going through areas where they have these sort of clouds, or is that a different cause for that kind of turbulence?
No, it's that. It's because the airliners have the power and they are constructed to resist to turbulences, but you can still feel them. And in light aviation, in small aircraft, you feel them a lot more, especially the draft, the wind draft.
Right. Okay, so it is the same phenomenon. The difference being that a private airplane weighs 100 times less than a commercial airplane, so the same force applied to much less inertia creates much higher tossing around of the aircraft.
Yeah.
Okay. One final question, because you also mentioned mountain wave turbulence, which was something which I think nobody else had heard of. Can you tell us what that is?
So mountain wave turbulence are really dangerous, and so that's why you have to pass another qualification to fly around mountain. And so it's because strong winds hit the mountain and it causes updraft on the windward side and downdraft on the leeward side. And so the updraft can be so strong that the aircraft struggle to descend, while the downdraft can push an aircraft toward the ground very quickly.
Okay, so just so we can visualize this, so imagine we're flying towards a mountain range. As we get closer to like the peak of the crest of the mountain range, we would have suddenly like a wave of wind pushing us up, and then as we go over it, we have another wave sort of pulling us down. Is that it?
Yeah, and small aircraft are not designed to resist to really strong upward or downward wind draft. And so you can stall really easily or crash. And
quite easily as well.
Yeah.
Okay, so this is something that has to be taken into account. So, I mean, what you're saying is that when you're going to fly, especially if you're flying in a small craft, you have to know very well what path you're taking and what's on that path, whether it's in the air or on the ground, because all of those are factors which would have an influence on how your flight would go or what dangers are there.
Yeah, exactly.
Yeah. But even around the mountain, you have orographic waves, which are caused by the interaction of the upward and downward draft, and so it creates waves in the air that are really circular motion. And if you encounter them even at a few kilometers away from a mountain, it's really dangerous.
Oh, wow.
Yeah,
okay.
and these waves can extend far beyond the mountain, sometimes up to 100 miles downwind.
Wow.
Yeah, so even if you pass far above the mountain, it's still very dangerous.
Yeah. So you have to
Okay. I would
keep
not have thought
control.
that. Is this also applicable to, again, the big commercial flights, or are they flying high enough that it's not really a...
No, it's high enough.
Okay. So if we could, I guess because cruising altitude for a commercial flight is around what, 12 kilometers?
1,000 feet, 10,000 feet. So
No, more than that. 30.
More than
Isn't it like closer to 30,000 feet or 32,000 feet?
No, it's 10 kilometers.
Right,
And so okay.
Okay, so 10 kilometers, unless you're flying over the Himalayas, which is not most of the flights in the world, you're high enough that these effects aren't really something you have to consider.
Yeah, absolutely.
Okay. Just out of curiosity, all that you're describing for a flight, is it also applicable if you're like in a helicopter? Or do you not know? It's
really different in helicopter because the poles, like the wing
right
above the helicopter creates different types of turbulence, but in mountains they are also it's very dangerous for them too.
I suppose because you're not getting lift in quite the same way with a helicopter than you would with a plane, the consequences would be different. Because you don't need, for example, for a helicopter to maintain a specific speed, whereas for a plane, for the lift to be maintained, you have to maintain a certain airspeed, right? Yeah,
and even when an helicopter take off or lift off, a small aircraft, if it's really close to the helicopter, it will damage the plane because they create such strong winds around them.
Okay, so basically airplanes are much, much more fragile than we thought.
Yeah.
Okay. I think we've gone through most of the topics that you guys brought up in your presentations. Is there anything that you want to mention that we left out, or have we gone over most of things?
No, I think it's okay.
Right, because I think a lot of the stuff that you guys talked about needed visual aid, and it's very difficult to just talk about them. But if there's anything... so at one point, one question... You talked about the Coriolis effect and why it's important to be taken into account. Do you want to give us a short description of what is the Coriolis effect? Because we sort of, I guess, tangentially mentioned it in physics this year.
Yeah. So I don't know a lot about this force, but from what I understood, it's the wind doesn't go in a straight line because of the rotation of the Earth.
Exactly.
And so it curves, and you have like several wind motion around the Earth based on where you are, like on the northern atmosphere, or if you are more at the equator, or in the north or south.
It depends on the latitude you're flying at.
Yeah, absolutely.
Yeah, in the northern hemisphere, they come to the white, and in the southern hemisphere, is a...
So I guess it'd be more the case for Myriam, because you will be continuing to do some physics next year. Coriolis effect is what we call a fictive force. It's when we, I guess to put it very simply, we apply the first law of Newton's mechanics, the principle of inertia, in a wrong frame, in a non-Galilean frame of reference, right? And then you see sort of weird behavior that you say, oh, there's a force doing it, but that's only because your frame of reference is actually an accelerated frame of reference. So it's a sort of a misinterpretation of what's happening, but nevertheless, it has to be taken into account, right? Because of the kind of phenomena that it produces, which are these winds which turn in opposite directions, the further up or down you go in terms of latitude. Okay. So,
But I thought that it was linked also, like in the northern hemisphere, the air turns clockwise, whereas in the south hemisphere, the air turns counterclockwise. clockwise.
Clockwise, yes.
Yeah. And so I thought it was caused also by the Coriolis force. Like I didn't really perfectly understood the link between those two, but from what we searched, we like saw that it was linked.
Okay.
In link with our presentation, these effects influences present patterns such as the rotation of storms.
Mm-hmm. Right. So
Obviously.
like typhoons or hurricanes in the northern or southern hemisphere, you mean?
Yeah.
Okay. All right. Well, I think we've pretty much touched on most of what we can touch on in the short time that we have. So why don't we end the interview as we usually do? I'll ask you guys what you, how you felt about the presentation, the topic. So I guess it was different because you guys were the ones who sort of came up with the idea of this topic. So you already had some interest in it, but maybe you found something during your research and during your presentation that you were not expecting or was striking. So just what was your personal experience with it, with the topic? Maelys, maybe you can start.
Yeah. I think the hardest part was to keep it clear and fun because it's a complicated subject.
Yep.
And concepts
and very technical,
like,
right? It has a very sort of a jargon that goes with it, and it requires a lot of like notions which have been worked over in many years and simplified, right?
Yeah, and concepts like lift or pressure can get complicated. So we had to simplify without oversimplifying.
Right. And was it particularly difficult for you since you, unlike Myriam, are not majoring in physics?
Yeah, I flew once as part of BI, but
Okay.
I loved.
Was it with Myriam?
I love that. No, without Myriam.
Would you fly with Myriam? Do you trust her? Okay, I think we have our answer in that hesitation.
Maybe after.
All right.
When she will certify. But it's really exciting. And I love planes and aeronautics. It's really interesting.
I take it you don't have much fear of heights?
Sorry?
Are you afraid of heights or not at all?
A little.
Okay. What I've heard is that even people who have fear of heights, when you're in a plane, you're so far up that you don't feel the height in a way that would actually cause a problem, right?
Yeah, absolutely. Because I fear heights. I hate to climb mountains or anything like that.
Okay. But in an airplane, you don't feel like you're high up. It just feels like you're elsewhere, right?
I think you're really, the view is mind-blowing, so it's incredible. It's an incredible feeling of, like you're free from everything.
Okay.
And you can see the horizon. It's really beautiful, but when you're flying like a fighter pilot, you're using instruments. It's a little different and complicated, I think.
Okay. And you plan on continuing on taking lessons and flying?
No.
No, you've stopped.
Yeah.
I'll take her.
Yeah, I was gonna say she's just waiting for you to get your license.
Yeah, absolutely.
Okay, and so you, Myriam, where's the origin of your interest in flying and aviation?
I think it's my dad for the interest in aviation, but in meteorology, it's my teacher because she's passionate about clouds, which is a bit weird, but
why is that weird?
No, but I don't know. She always take a lot of pictures of every cloud, and I'm like, I don't see the point of doing that. But but the way she explains the meteorology is so it's easy to understand. It's like you're smart, but you're not really. She's smart, and so she makes you feel smart.
Okay. So I guess that's what makes a good teacher, right? To bring something complex not only to your within your grasp, but also to give you the passion that they have for it, transmitting that to you as well.
Yeah, absolutely.
His dad knows where a plane is coming from and going just by seeing it.
Okay, that's a very interesting point of view. And I guess neither of you guys, knowing the dangers that sort of lie in flying, it's not turning you off of it. It's actually getting you more interested in it, knowing all the details of, how what goes into it and all the things that could go wrong. It's not something that scares you?
Like when you fly, you prepare beforehand, so it's really safe. You don't fly unless the weather is perfect or the wind is okay, and if you have the skill to fly when the wind is strong, you know it, and your teacher guides you through it. So I've never been scared at all. Like, I know she's there, and so yeah, maybe that's why I'm not scared.
Okay, but do you think that you'll have that confidence the first time that you'll do it without her?
No, I don't really want to fly solo because I don't trust myself.
But that's the end goal, right? That's the end goal.
Yeah, I know, but it's really different because she knows a lot and I know so little that I don't think I'll be like as good as her. And
well, not at the start. But...
yeah, that's not the point. But it's safe to have someone who knows everything beside you. And when you're alone, I guess that's where you learn everything.
I think that's you could say that as much about driving a car, driving a bike, to learning to do even physics or math in class, right?
Yeah.
It's the whole idea of being accompanied and being sort of an apprentice, and then until it's your time to go on your own, right? It's the story of life. All right.
Yeah.
So Maelys and Myriam, thank you very much for your presentation on the aspects of meteorology taken into account in aviation. We could sense that it was very close to your heart, both of you, and it was very quite original, and we learned a lot of technical stuff. And now I'm going to be afraid of going into airplanes. Thank you very much. So that is Physics Bites for this week. We hope that you enjoyed this episode, and we would love to hear what you thought about the topic in the comments section. If you did enjoy the show, then subscribe to our podcast, share it with your friends, and be sure to leave us a 5-star rating on whatever platform you're listening on. And more important than all of that, come back soon for a new episode.